In this video, we are going to see how to edit our own 3D representations for land using Accurender Plant Editor. We will also look at other tricks, such as setting up different appearances according to seasonality or saving pruning options. To explain each of the parameters, I am going to create a new species. Remember, you can also edit or adapt any of the models already incorporated in Land Design. We will start by generating a new file based on the template that best suits our needs. In this case, I will use the standard one to represent a specimen of the species Tilia cordata. We then rename it with the species name. And once the editor is open, we will see the structure and components of the plant we are editing in the upper right corner. The top commands will allow us to add elements like the trunk, branches, or leaves. The last one will be used to cut, that is, to remove those components we are not interested in by selecting and cutting. And, with the selection of checkboxes, we can hide the elements we are creating. Now let's look at each element and its editable parameters. We start with the trunk. The first thing to configure is the number of nodes. Since we want to start with a single trunk, we will keep this value at 1. The probability field indicates the likelihood of this element appearing. A value of 1 corresponds to 100%, so it will always be visible. But we will go into detail about this field when we talk about seasonality. For the size, we have 2 fields to define. First, the width at the start of the trunk. We can thicken it a bit. And second, the height, which I will also reduce. You can take these values as a reference. How are we going to use these species? In Land Design, it will be there where the height is defined with a specific unit of measurement. What matters most to us here is achieving the correct shape and proportion of the representation. Moving on to the shape field, the first parameter allows us to gradually thin the trunk along its length. With a value of 1, the trunk will maintain a uniform spring, but if we reduce this number, it will become thinner towards the end. Okay, the next 2 parameters will directly depend on the mesh configuration. The value we assign to faces corresponds to the number of sides that define its outline. If we set it to 8 sides, the trunk will have an octagonal section. The larger this number, the closer it will resemble a circle. However, we should always work with the minimum value we consider to minimize file size and speed up subsequent work processes when we review with this species. E-joins will indicate into how many segments the mesh is divided along the trunk. Since it's a trunk that grows vertically and without much curvature, a value of 12 or even less will be fine. The bend parameter defines a curvature, and in the side drop-down, we can try different curve patterns. Quickness will create an irregular undulation. We're going to leave it quite straight for now, and the concepts will be better understood when we create the different branches. In the field, position, offset, will indicate a lateral displacement from the origin point of coordinates, and offset, a vertical displacement, meaning we can give a positive value to raise it above the ground plane or a negative one to lower it. From the angles field, we will control the inclination. The values in this field correspond to degrees, so a value of 90 means perpendicular growth, and a value closer to 0 means completely vertical growth. In horizontal start, we indicate the orientation. If we increase the angles in this field, our trunk will rotate around the z-axis, rotating with it all the sub-elements, such as in this case, the branches and the attached leaves. Finally, we have material and texture. By clicking on the image, we can select one of the predefined options or one that we have prepared previously and subsequently scale it by segment, by white, or by image scale. Once we have the main trunk, we will add the next level, which is the branches. If we didn't have them created, we would select the trunk level and add a new branch. In this new element, we will find some of the parameters we just saw and others that are a bit more detailed. To start, we indicate the desired number of nodes. The next value indicates how many branches we want for each of these nodes. I'll try with 3 for now. At this level, we can better appreciate the probability. With a value of 50%, only half of these branches will appear, but I'm going to increase it, leaving it at full. We define a thickness for the initial branches and another for the final branches. If we use the same value, they will maintain the same length. Now, if we give greater thickness to one of the 2, they will, in turn, be longer. We also adjust the length and let them taper towards their endpoint. Now, let's take a look at the different curvatures. With a positive value, we see that they curve slightly upwards, but we can use a negative value to invert it. Exploring the curve options, we find different patterns. The standard generates a single arc. The horizontal tends to flatten the curve. That curve generates a double curvature, which we can also invert. And finally, hook or hook, which curves only at its end. Let's leave it on that curve to create this double wave, and we'll give it a negative value so that the branches end upwards. We reduce the value of segments and faces, and we can increase the wave a bit to make them more irregular. In position, we now have two values, the point where the branches originate and the point where they end. Using a value of 0.5, they will start to distribute from the middle of the trunk, and with a value closer to 0, they will start from the base. I will use 0.35 for the start and 1 for the end point, and I'll leave the rest as it is. For the inclination angles, we indicate an angle for the branches at their starting point in the same way. And we can indicate another one where we want them to end, for example, one that will be more vertical. The last parameter is the degrees of separation with which these branches are distributed. It will be clearer with a single node if we try with angles of 90 or 180 degrees. For a single branch per node, 130 is a value that usually works correctly to provide a homogeneous distribution. But, if I go back to the 3 original branches, it's better to use 90 or 80 so that it's not too symmetrical. With the plus-minus boxes, we indicate a variation factor with respect to the previous value to also help us avoid this symmetry. And remember that with this other value we can rotate the starting point. By clicking on the image, we can add a new material by selecting a new texture or use one of the materials already created. In this case, we keep the previous one and scale it. Before adding the leaves, we add a second level of branching from the one already created. I'm going to configure this one a bit faster. We can create as many branches as necessary to achieve a representation closer to reality. However, starting from the third branching, we will need to select the first level of our scheme, the one that contains the species name, and increase the maximum branch level to allow us to continue adding. Now, we can proceed with a third level of branches from the previous one. You can try the values and configuration that most resemble the shape you are looking for, but remember to work with the minimum number of faces. The smaller the branches, the less level of detail we need. And now, from this level, we can add the component to form the leaves. In the case of the leaves, we first select the texture we are going to use. Right-click. To see which material is being used, I will use the existing material for these and replace the associated image. For this, we will need to have prepared a texture with the cutout of the leaf we want to preview, with the background removed and saved as a PNG to maintain transparency. We specify the number of nodes and configure the size. First, we select an option from the drop-down to indicate the aspect ratio of this image. Custom would be the personalized option that allows adjusting the texture image to the specified width and length. Match texture is the option that maintains the original proportion of the image. We can adjust it based on a single value, which will be the width, and the length will adjust automatically. And finally, the lock option, which locks the proportion we want. That is, if in the custom option we have defined a proportion different from the original, by selecting the lock option, we will be able to increase or decrease the size of the sheet based on the width, and the length will automatically adjust, maintaining this aspect ratio. I'm going to set it to match texture to respect the image proportion of the sheet and reduce its size. Another option we find in the sheet settings is the type. We have the option to use a curved plane, as you see in the viewer, or 2 crossed planes. This option is more useful for simulating small-sized flowers or fruits with a minimum number of faces. The next thing we need to define is the number of segments, which will depend on the curvature we want to give it. The bend option curves the segments along the sheet. We can use 3 segments in this direction and a negative value of 0.05 to curve it downward. And curve will do the same in the opposite direction. We will use 2 segments and a value of 0.15. We set the desired position and angles, and we can check this box so that the leaves orient directly towards the branch they are on. Well, as we can see, the top part of the tree hasn't been sufficiently covered, because with the curvature pattern we've indicated, we can't achieve more verticality in the upper branches, even with the minimum value. So we're going to create another branching from the trunk to achieve the conical shape we're looking for at the top of the tree. To do this, we're going to make a copy of all the previous branches. We can do this with a click on the level from which we want to copy, drag it to the trunk in the diagram, and release. Now in the diagram, we see them duplicated and we can rename them. I'm going to give a probability of 0 to the second one so that it is not visible. We'll use the first branch for the lower ones, so we adjust the position by keeping the origin point and lowering it at the end. We can also give a greater opening angle. At the end, we go back to deselect the second one. We'll use this one for the upper branches. We'll reduce the number of nodes to 7 and maybe 2 branches per nodes. We'll change the curvature to standard and use a very reduced curvature so that they are more vertical and thus cover the upper part. In position, we'll do the opposite of the previous one. We keep the end point and raise the starting point. We also adjust the angles. Combining different branches can help avoid very symmetrical trees and give them more naturalness. If we now view the general menu by clicking on the species name, in this menu we see the materials or textures contained in this file. We can rename them or, with a right-click, delete all those that are in use before saving. We have the maximum level of branches that we have seen, how to use, and also a slider that selects which season we are viewing in the viewer. Let's see how to configure different appearances for each season. Since it is a deciduous tree, we can position ourselves in the winter season and decide that in this season the tree does not show its leaves. To do this, we select the element we want to make variable, in this case, the leaves. We click on the season drop-down and can set a probability percentage for each of these seasons. For example, 0 in winter. In this case, since the leaves of branch 2 have been created by copying from branch 1, they retain the same property. If we now look at the leaves of branch 2, it has copied the seasonality of the previous one. If we want them to function independently, we must create it manually or save the file and reopen it to break this link. To represent the rest of the seasons, we can incorporate other leaves with different textures. If, for example, we create a new leaf, a copy of the previous one, remember to save and reopen. File to unlink the leaves. We create a new material from a new texture and select a texture for the autumn season. We are going to configure it, leaving only the 100% appearance in this season and, therefore, in the previous leaf. We will have to edit it so that in autumn, when the orange leaf appears, we don't see this green one. We copy it to the second branch, and with the slider in fall, we will see the change we have applied. In this way, we can play with the possibilities and combinations of textures to achieve more realistic results. We can also use the leaf component to create flowers, fruits, or different elements. In this file, I have created a couple more branches to distribute the flowers. One of the options we have, as you can see here, is to use a centered image of the complete flower as a texture and use the option Men Plane. With the segments set to 1 and without any curvature, we would generate this volumetric appearance. This resource is the most suitable for representing small details and minimizing the number of faces, as in this case. But we can also create flowers in greater detail, element by element. We would start by creating a leaf with the image of a petal. We adjust the size. We can give it a single level with 5 leaves. We would add curvature in both directions. We position it almost at the edge. We orient it and set a wider angle, for example, 80 degrees. And then, we would do the same with a new material for the pistil. We reduce it considerably. In this case, we can use a crossed plane to make it appear cylindrical. We will curve it only along its length. And this one we do place at the edge. We also slightly close the angle so it remains inside. This would be another way to create these elements, although in this case, it is not advisable to reach this level of detail for a tree, because, as you can see in the lower left part, being such a detailed element and repeated so many times, it considerably increases the number of segments or faces of this mesh that we will later export. And if we are going to work with a large number of specimens, it will make working with this modeling much slower and more complicated. Therefore, it is more convenient to use the first option and finish setting up the stations. To conclude, the most recent addition to the editor is the pruning option. I am going to open another file to show it. If, for example, we had configured this tree with 3 branches instead of 2, using one branch for the top, another for the middle, and a third for the lower parts, we could select the lower branches and indicate that they belong to pruning option A. Once indicated, in the plant's general menu, we see the pruning options that we can activate or deactivate with the checkboxes. By activating option A, in this case, the lower branches we just indicated will be hidden. As you can see, there are options A and B to allow for up to 2 saved options. This option can be useful for having the same species with different possibilities, with a more natural appearance and growth, or alternatively, a more trimmed option to place, for example, in urban contexts. Once our species is finished, from the top option, we can view the render view to see the final appearance and save. If you are determined to create your own representations, I encourage you to review the land's design models to discover the multiple possibilities this editor offers.